Hello and welcome to the Equinor Summer STEM series. Again, this is brought to you by Equinor, as it says in the title, and the University of Houston, specifically the Teach Houston program, a program for aspiring math and science teachers. I'm a math teacher and your host, Ms. Foz. So let's get right into this. Data, all about that data today. This is mission 2, so hopefully you've already done mission 1. If not, I highly suggest you do, but it's not needed for this mission. So this is StorageWars part 2. Today's mission, again, you've been given a ton of data. You need to figure out 4 ways to store it. So how do you get to your best friend's house? You're going to go to this URL so you can copy and paste it, type it in, or on the handout, you can actually press Control on your keyboard and click it to open it on up. And it is going to take you to this amazing website about bar graphs, and you're actually going to make your own bar graph. So on the handout that goes with this lesson, make sure you read the instructions carefully as you're going to input your own data as well. You are one person getting added to this data, so you're going to add 1 to whatever category applies to how you get to your best friend's house. So really quickly, I'm going to show you where it is going to take you once you click the link. It's going to show you again this amazing website about bar graphs. Go ahead and read all of this information. It's really important for you to understand bar graphs fully. And you're going to go ahead and read this as well, histograms versus bar graphs, since this section is actually really important to this entire mission. So go ahead and do that. And then at the bottom, you're going to go to the Here's More section and click Make a Bar Graph, where we are going to input our data of how you get to your best friend's house. So here is the bar graph. You can see it's already pre-selected. You're going to go to Raw Data. And here's where you're going to put in your data. Again, change the title to what we're talking about in this situation, how you get to your best friend's house. X, you can change it to category, meaning like, what is this going to describe? Bike, bus, all of that. We can put modes of transportation. And then you can change the Y value to what this would represent as well. So the most important part I want to show is how to input the data. You're going to put in the category, for example, bike. Asterisk, which is if you press Shift and then 8 on your keyboard, you should get that little asterisk. And then after that, you're going to put the number of people who ride the bike to get to their best friend's house. So let's say that's 6 people. You can see it even pops up in real time and changes it automatically. So that is how you put in data. And after you're done with each group, you're going to put a comma so that it separates each group and their data points. So once you are done with that, you can see I'm not done here, but go ahead and you do that. I will let you discover that. You can actually click line graph, dot plot, a pie graph, or a histogram and see all the different ways that you can see the same data, which is amazing. And you can also print or save this to your own computer or desktop or device so that you can keep it for your memories. So pause this video, check this out, and then press play when you are ready to continue our mission. So hopefully you had a lot of fun playing around with this. Again, don't forget to check out the other representations, and don't forget that you can totally save your bar graph or any of the graphs really. Are you ready for a bigger challenge? Go ahead and click that tiny URL or type it in into another tab. It's going to take you to this quick 4-minute schmoop video about histograms. It's really quick, really easy to understand, so do that because it is crucial for the next part of our mission. So pause the video, do that, and then come back when you're ready. Now it's time to create a histogram. So you're going to go to, again, student.desmos.com and enter this code. You do not need to capitalize or put a space. You just put Y for F96, and you'll probably need a Desmos account beforehand. So before you put in this code, actually, I would make a student Desmos account. It's fairly quick, free, and easy, and then enter this code. Take a guess at the first 2. Don't spend too much time overthinking these. Try your best to get an exact answer for slide 3, though, and then come back. So this is a lot of data for the best animated film. You should have answered 15 for slide 3. If you came up with 16, you probably counted Wreck-It Ralph, which is 120 minutes. The rule says at least 100, but less than 120, which means only numbers 100 through 119 should have been counted. So Wreck-It Ralph, unfortunately, is out. So now enter this code, GFZFZ3, and keep going. Don't worry if you make a mistake. You can always check your work on slide 6, or you can go back and change any mistakes. Remember that at least 2 hours means 120 minutes or more. So pause now and come back if you want a hint. So here's your hint. The total number of movies is 50 movies. The first 2 rows are fairly easy. You already have 15 in the 4th row. And the last 2 rows are also easy. So subtract the total number in the rows from 50 to get the highlighted row. So going on to best regular film, now enter this code, GXRUEX, and come back when you're done. The original question, how do you think the lengths of the best films compare to the lengths of the best animated films? What do you think? By comparing the histograms, it appears that animated films tend to be shorter. If you look at the histograms, where is the peak in each one? In the best animated films, it is between 80 and 100 minutes, since 27 movies are between those times. In best films, the peak is at 120 to 140 minutes. So you can see that best animated films has shifted more towards the smaller amounts of time, whereas best films has shifted towards the longer, lengthier films. Thinking time. Which representation is easier to use to figure out how many movies are at least 2 hours long? The table or the histogram? Which one would you use to figure out how many movies are at least 2 hours long? Pause the video, think about it, and then press play when you're ready. I would pick the histograms. You can see 120 minutes is 2 hours long, so we're looking at the right of 120. In both histograms, you can see how many movies are that length. So I would pick the histogram for this question. Question number 2. Which representation is easier to use to figure out exactly how long the animated film Frozen was? The table or the histogram? Again, think about it, pause the video, and then press play when you're ready. I would pick the table. It tells me exactly how long it is, 109 minutes. Whereas in the histogram previously, it does not tell you where Frozen is, nor does it tell you how long it is. So thank you for joining me today for Mission 2. Make sure to go to Mission 3. And remember that every day you learn and grow. I'll see you soon for Mission 3. Have a great one.